All right, so we're going to talk about laws of exponents. Let's say I have 3 to the 0 power. You can do this in your calculator. You also have done this before. Anything to the 0 power is going to be 1. So even if I have a negative number, if it's like this, my answer will be 1. Now, if I had negative 4 to the 0 power, what that's similar to is taking that negative, placing it on the outside of parentheses, so that 4 to the 0 will be 1, but the negative in front will make that a negative 1. So that's the only time when you see a 0 power that it wouldn't be 1. Maybe you might have something like negative 5 times 2 to the 0 power, which would be similar to the problem right above that. So you would have a negative 5 times 1, and your answer would be negative 5. Okay, so those are your rules to the 0 power. Now let's take a look with multiplying. So let's say, for example, I had x to the 7th times x to the 5th. Well, we have the same base, which is x, so we keep the base and we add the exponents. And again, I think that that's kind of review for you. Now, what happens if I had something like x to the 8th times x to the 2nd, and all of that would be over x to the 7th? Okay, so now we're combining a little bit of multiplication and division. So again, let's remember that if you have the same base, you add the exponents, which would be x to the 10th, and then we keep that x to the 7th. Now, if you remember from when you learned these the first time, when you have division, again, we have the same base. We have 2 x's there, so we keep the base, and we subtract the exponents when we have division. So that would be x to the 3rd. All right, let's look at some other problems. Now, perhaps maybe you would have something like x, y, that quantity to the 5th power, and then that whole thing over x, y cubed. Now, notice that in the numerator, the x and the y are being raised to the 5th power, whereas in the denominator, only the y is being raised to the 3rd power because there's no parentheses there. So we can rewrite the numerator as x to the 5th, y to the 5th, and then we just keep the denominator as is. So now we're going to do our division, and again, remember when we have division, we keep the base and we subtract the exponent. So we're going to take one letter at a time. So in this case, I'm going to get x to the 4th, and then I'm going to get y to the 2nd, and that would be my answer there. Now, another variation of multiplication that you may see is something like, let's say we have 1 half x squared, that whole quantity cubed. Okay, well, that's similar to the one right above there where the x and the y were in parentheses and that whole quantity was to the 5th power. So what this means is that cube has to go through to everything on the inside of the parentheses. So really what we're doing here is we're doing 1 half and we're cubing that amount. And then we're doing x squared, and we're cubing that amount. Now, 1 half, if we cube that, means 1 half times 1 half times 1 half, which would be 1/8. Now, if you recall, when you have a power to a power, this is a little bit different because we have one base, which is the x, and then we have 2 powers, the 2 and then the 3. So when we have a power to a power, we keep that base and we multiply those exponents. So our answer is 1/8 x to the 6th. Alrighty, let's just try one more just to make sure we got that one down. So now we have 2x, let's do that quantity to the 5th power, and then 2x, x cubed. Okay, so the same deal again, we're going to be doing 2 to the 5th power, and we're going to be doing x to the 5th power. Okay, in the numerator there. And then in the denominator, remember, because the 2x is not in parentheses, it's just the x that's being cubed. Okay, so then we're going to do 2 to the 5th power. So that's 2 times 2 times 2 times 2 times 2, which is 32. And then we have x to the 5th. And then down here on the bottom, we have 2x cubed. Okay, now we can divide the 32 by 2, which would give us 16. And now we have division with exponents. We have the same base, so we keep the base, and we subtract the exponents, which would be x to the second, and there would be our answer. All right, now what I would like to do is look at something that's maybe a little bit different than what you're used to seeing. So for example, we're going to look at negative exponents. Okay, and I don't believe you've done negative exponents. You may have. And if you have, then it's a great review. All right, negative exponents. So for example, let's say I have x to the negative third power. That is equivalent to 1 over x to the third power. Okay. If I have y to the negative seventh power, that's equivalent to 1 over y to the negative seventh power. If I have 8x to the negative second power, now only the x is raised to the negative exponent because there's no parentheses around the 8 and the x. So the 8 does not drop down, only the x does. Okay, because the 8 is not involved in that negative exponent, it just stays where it's at, which is technically in the numerator. So the moral of the story here is when you have a negative exponent, like we do in these 3 particular examples, you can make them positive by dropping them to their opposite positions. So for example, in here, okay, x to the negative third really technically is over 1, so we move it to its opposite position. Since it's in the numerator here, then what we're going to do is bring it to the denominator here, okay? But now let's look when we might have things that are a little bit different. So let's say I had 2c over a cubed times c to the negative second. Now let's look at that, because if we look at that, everything is fine except that c to the negative second. Now, what we can do here is, since there's nothing wrong with the 2c, we're going to leave it. In other words, there's no negative exponent. And a cubed is also fine, okay, because that's not a negative exponent. However, we've got this guy right here. So remember, if we want to make things positive, we move them to their opposite position. So for example, right now, c to the negative second is in the denominator. So what we're going to do is we're going to bring it up here, and look, now it makes it positive. Okay, so since it was in the denominator and negative, we move it up to the numerator and make it positive. Now let's just kind of simplify this a little bit. So we're going to have a to the third in the denominator now. Now, this 2, we're just going to bring that down. Now look at what we have. Technically, we have c to the first, and we have c to the second, and they're being multiplied. So remember, keep the base, add the exponents, and there is your answer. All right? Okay. How about we just try a few more just to make sure that we get the hang of this. So let's say we have 4d to the negative first over c d to the negative third. Okay, well, nothing wrong with the 4, nothing wrong with the c. There's no negative exponents associated with them. So I leave those guys alone. Leave that one alone. Now, both of our d's are negative, so what we're basically going to do is flip-flop their positions. So we're going to bring d to the third up, because in the denominator it's negative, so we can move it up to the numerator to make it positive. And the same thing with the d to the negative first in the numerator. To make it positive, we bring it down. Okay, and now we can just go an extra step further, and let's just simplify this a little bit. So we have 4. Now let's do our division here, keep the base, subtract the exponents. So that's going to be d to the second. Now, since d to the third is higher than d to the first, that d to the second is going to be in the numerator. And then we're over c, and there is your answer. Alrighty? Okay, let's try another one. Okay, so then let's just try a couple more. So let's say I have 9x to the negative fifth over 3x to the negative eighth. Let's flip-flop the positions with the x's. Well, then, so 9 divided by 3, by the way, is 3, so I'm going to leave that there. So now that x to the eighth comes up, and that x to the x to the positive 5, right? Because it comes down to the denominator and becomes positive. And then let's just keep going, and we have 3 x to the third power. All right? Okay, let's just do another one. We're having so much fun, we may as well keep going, right? Okay, so let's say we have this, and then in the denominator we have x to the third, y to the sixth. All right, now, in this case, I would advise against moving anything until you simplify that numerator a little bit. You have a power to a power. And remember, when you have a power to a power with one base, you keep that base and you multiply the exponents. Now, in multiplying the exponents, look what happens. So we don't even have to deal with those negative exponents at all. Oops, that's a 6. All right, so now I see that I can simplify this, and 6 is higher, so I'm going to keep my answer in the numerator there. So that's going to be x to the third, because 6 minus 3 is 3. And then I have y to the sixth there. All right? So let us just see, let me see if I can come up with just one more for you. How about if I had something like a to the negative second over a to the fourth, b to the second. Ooh, I like this one. Okay, so now the a to the fourth and the b to the second, not a problem. But the problem is we have a to the negative second in the numerator. So we want to bring that down in the denominator. Now, if we bring that down in the denominator, there's really nothing left in the top, but we use the 1 to hold its place, so to speak. So I'm going to keep that a to the fourth. I'm going to keep, that b to the second. And now I'm bringing that a to the negative second down, so now it's a to the positive second. I know that looks a little ugly, so let's fix it, make it a little prettier. And that would make that a to the sixth, and then b to the second. So I think that gives you a pretty good idea now on negative exponents.